In question 1, I want you to be able to graph a quadratic function by doing the very basics of axis of symmetry, vertex, y-intercept, and its reflected point. So in order to find the axis of symmetry, we run our calculation of x equals our negative b over 2a. Just to review a little bit about what negative b over 2a is, our equation is x squared minus 6x plus 4. The value of a is always the coefficient of your quadratic. So a is this 1 that wasn't written there. If it's not written, it's always a 1. And b is this negative 6 that's sitting there, and c is always your constant. So in this problem, what we want to be able to do is we want to be able to run our calculation of a negative of the value of b, which is a negative 6, all over 2 times a, which is 1. So it'll be the opposite of a negative 6, or just 6 over 2, which is 3. Now what this finds for us is our axis of symmetry, and I want to graph the axis of symmetry right away on our graph. And I'll try to use these lines that are a little bit easier to read. It is a vertical line that is dashed. It's part of our graphing aid. It's not an actual part of our parabola, but it's our graphing aid. That's our line of reflection. And what we've talked about repeatedly is that our vertex, so I'm just going to plot a point on here. The vertex is always going to be on the axis of symmetry, and that vertex can slide up and down. I can just get it to move. So our vertex has to be on the axis of symmetry, and because it has to be on the axis of symmetry, every single ordered pair has to start with a 3. So I know the ordered pair of the vertex is 3 comma something. I just got to find out what that something is. So I've got an x, and I need to find the y value. So in order to find our vertex, what we do is we plug in into the function f at 3. It's always the value that we get for our axis of symmetry that goes into that. So now it's going to be 3 squared minus 6 times 3 plus 4. And 3 squared is 9 minus 18 plus 4. This is a negative 9 plus 4, which is a negative 5. So our vertex is at a positive 3, negative 5. So I'm going to fill in this. Positive 3, negative 5. And that was pretty close where I had it parked. 3, negative 5, and that's our vertex. So what we found so far is our axis of symmetry, and this last thing that I found, the 3, negative 5, was the vertex. Okay, and now we're going to find the y-intercept. By definition, the y-intercept is the location where your graph crosses the y-axis. So it could be any point that I'm choosing the red point up and down, but every time I have a point on the y-axis, the x-coordinates have to be 0. So that gives me the connection to, okay, if I want to find the y-intercept, I have to take the function f and plug in an x value of 0, because I know my ordered pair is going to start with a 0. So if I do that, it's going to be 0 squared minus 6 times 0 plus 4. And that is why we've said consistently, once we plug in these zeros, these things become calculations of 0 plus 4. It's always just the constant, so I have an ordered pair of 0, 4 as the y-intercept. So I'm going to put that in the correct location, 0, 4. So now I know what half of my graph looks like, and I'm going to graph it. It's a U shape, so it's got to be coming up here and looking like that. Now I want to graph the reflection point of the axis of the y-intercept. So that means I've got this ordered pair 0, 4, that is 1, 2, 3 units to the left. I got to go 1, 2, 3 units to the right. So now I have an ordered pair 6, 4, which is the reflected point, and it also gives me the other half of my graph. So that means this gives me a pretty good indication of what the shape of that graph looks like. Okay, so I've got my ordered pairs on there. I'd like to just put it on the graph as well. This y-intercept is 0, 4. So we got the y-intercept, the vertex, its reflected point, and the axis of symmetry on our graph. Check, check, check. Everything's done. That's the requirements for those types of problems.